Okay, welcome back. What I want to do is to continue with Level 3 NVQ Diploma in installing electrotechnical systems, etc. etc. Now, again, we are continuing with Unit 3 or 4, and if you look at the previous videos, you'll see that it follows on. Now, Unit 3 or 4, and that's your EAL reference number, okay? This applies to EAL as well. And you can see here, session 5, earthing and bonding. Let me go in a little bit so you can get that yourself and see it. Session, earthing and bonding, okay? Now I want to be sure that everything is clear and is in view, okay? So bear with me while I check and recap at certain points, okay? Okay. Now the student will be able to gain an understanding of earthing and bonding. And as you will be the electrician doing any job on site, that responsibility falls to you, okay? There's no shortcuts, there's no excuses, you are responsible. So you must consider safety, safety, safety. Now let me go and make sure I can get, now it clearly states here, earthing and bonding, okay? Clearly states. Now let me pull out a little bit so we can make sure we get everything in view. Now the intake position of an electrical installation highlights two aspects that are commonly misunderstood, earthing and bonding. Now this is your circuit protective conductors, okay? They will come back from whether it's your lighting circuit, whether it's your ring main circuit, whether it's your cooker circuit in the kitchen. It will come back to this point, to your earthing point in your consumer unit. Earthing is different to bonding, and although related, have two very different purposes. Now this is bonding. Now here we're bonding the extraneous pipework to make sure that it cannot reach a positive potential. In words, that it doesn't become live at 230 volts. Okay? And you're bonding down the gas, you're bonding down the pipework, okay, etc. Now this is essential in the houses because although certain points may come in plastic from the external, your copper pipework inside the house could still raise a potential danger. Okay, so this is your bonding, main protective bonding conductors. Okay, and I normally bond down in 10 mil basically because it gives you make it futuristic basically in due course, and it will cover most possible eventualities. Okay, but that's just me. But please go with what you feel the IE regs has stipulated for your particular circuit or particular work in hand. And earthing conductors. Now here is the main earthing conductor. It goes to here. That is constant. Okay. Your electrical circuit will then come back to here. So let's say lighting out, it will come. Its earthing terminal will come back to this point here. Any pipe work that's within your vicinity will then be bonded down to earth, okay, and will come back to your consumer unit bonding point, okay, and that's what earth bonding relates to and means. Let me just go back now. Let me just move in so you can make sure you can get a full picture of this event. Okay. That's your meter, and that's your protective fuse supplying your consumer unit. Okay. Let's make sure we get this into view. Okay. Now again, look at your IEUX and your on-site guide. Okay, because your on-site guide provides you with a great deal of information that you can use it. Okay. Now, bonding. It is necessary to define the term we use when dealing with both bonding and earthing. Dealing with bonding first, we have equipotential bonding or bonding, protective equipotential bonding, and bonding conductor. Now, equipotential bonding or bonding is an electrical connection maintaining various exposed conductive parts and extraneous conductive parts at substantially the same potential. Okay, and let me just go back a little bit, show you what we're talking about. We're talking about this part here, these extraneous parts. Okay, these parts here, as I've mentioned before, these are your extraneous parts, and these are what we're now looking at in a more defined reference. Okay, let me just go back forward now to where we were. Okay, now protective equipotential bonding is equipotential bonding for the purpose of safety. And again, you would be doing that equipotential bonding previously based upon what I've just shown you as well, because that too is a point of safety. Now here we have earthing, bonding, and bonding conductor. Now bonding is not the same as earthing. No, it is not. The purpose of bonding is to ensure that under earthfall conditions, exposed conductive parts are at the same potential, and preferably 0 volts. Okay. Earthing is used to clear a fault by causing a protective device to operate quickly. It does this by providing a path for fault current to flow. And you will see in one of the videos the earth fault loop, and this is now referring to your earth fault loop reference point. Okay, so look back at that if you haven't seen the video already, and look at the earth fault loop, as the earth fault will originate at a given point. Okay, the speed of operation will limit both the duration of the fault, thereby limiting the shock risk and the heat that will be generated within the cable during the fault. A bonding conductor is a protective conductor providing equipotential bonding. This will be in the form of either a main bonding conductor linking together extraneous conductive parts and the MET, or main earthing terminal, or a supplementary bonding conductor linking together exposed conductive parts and extraneous conductive parts. Okay. Let's just make sure we can get it all in, okay? And it's on full screen. Okay. And here we have our extraneous conductive parts, okay? Now look at what BS7671 has said. Let me move into it, okay? So we can see it in view. States an extraneous conductive part is a conductive part liable to produce a potential, generally earth potential, and not part of the electrical installation, okay? Central heating pipework needs to be bonded, okay? Structural steel work, again, you'll need to be bonded in one form or another. Hot water supply will be bonded, okay? Now the general rule is that anything metal comes out of the ground, and we can assume that the ground is at earth potential, then that metal work is an extraneous conductive part. Let me just bring it up a little bit more so you can see it, see what we're saying, okay? And let me just go in towards it, and I will pan that way, okay? So you can read this for yourselves now. And I will pan back. Okay. Okay, you can see that for yourself. Let's get it all into frame, okay? Now I've made it quite large so that it's easy to read. You don't actually have to strain your eyes, anything of the sort, okay? And that's what I've done here. Okay. Okay. Good. Thank you. And here we have exposed conductive part. Okay, so again, BS7671 states an exposed conductive part is a conductive part of equipment which can be touched and which is not a live part, but which may become live under fault conditions. So you need to take that into account. Therefore, if you're dealing with trunking or you're running cables into trunking, your trunking should be earth. There should be an earth, which if you have your lighting switch coming here, there should be an earth coming with your lighting cables, okay? So even if you use two single cables here, then you need to run in a separate earth with it, and that must come in from your fuse board or wherever you're taking your feed from, okay? We've seen central heating pump here as well, okay? And your cooker. Examples include metalwork of a night storage heater, immersion heater tank, electric shower, central heating pump, mechanic metal clad accessories, okay? So all these should be, any exposed conductive part should be earth. Again, remember, safety, safety. If someone gets an electric shock because you failed to earth a particular component or an exposed metal part, it comes down to you, and you can now be prosecuted, okay? So bear that in mind. I believe the regulations came up a couple of years back. It's specifically assigned to electricians and gas engineers. But please don't hold me to that. Please feel free to check this out for yourselves. The information may have changed since, but I doubt it very much. Okay. Anything else do I need to look at? Okay. And here you quite clearly state not everything that is metal is necessarily an exposed conductive part. But again, remember the terminology: safety, safety. If it's metal and it is exposed, bond it or earth it. Just checking that I've got everything in, okay, that nothing is missed out. Okay, thank you. And here we are looking at automatic disconnection of supply. The protective measure automatic disconnection of supply combines basic protection and fault protection. Okay, and let's just go in here. Protection by insulation of live parts, and again regulation 416.1. Now bear in mind that these regulations may change, so be sure that you're looking at the right section in regards to the 18th edition of the IEE regs or IET regulations. Okay, and you're looking for automatic disconnection, so that would be your main head topping title. Okay, distribution board, and this would be a three-phase earth and neutral board. Okay, because you'll need a neutral on here, because it will allow you to take off single phase supply systems. Circuit identification details, again it tells you here which regulations to see and to be looking at, and it's quite clear. Okay, you can read that for yourself. Okay, you don't need me to read it for you. And here we have basic protection is provided by insulation of live parts and or barriers and enclosures. Okay. Now, fall protection is provided by protective earthing, protective equipotential bonding, and automatic disconnection in case of a fault. And again, you can see clearly states there regulation 411. Again, be sure you're looking at the regulations for any modification or changes in regards to the IEE IET regs 18th edition. Okay, let's come back a little bit, make sure we get everything in. Okay. Okay. Looks like we have. Okay, thank you. Good. Here we have fault protection. Okay. The voltage between metal to be very small. Okay. So if we have a fault occurring, we need to be sure that the voltage, and please note that U represents the voltage. Okay. Metal socket, box, exposed. These will always be earth, especially if they're metal. Okay, CPC, bonded connection to your earth, grounding, and again these are main protective bonding conductors, bonding these components to your earthing terminal. Okay. Now again, remember that your earthing terminal will be in your fuse board or your consumer unit or your three-phase and with earth and neutral board systems. Okay, it will be there. Again, safety, safety, safety. And again, please remember that U in our case now represents voltage. Okay, let's go back a little bit to make sure we get this into view. Okay. Okay, let's go on and make sure we get everything in line. Now, the key aspects of fault protection in the majority of cases of ADS the designer is required to ensure that under earth fault conditions, a protective device will interrupt the supply, and the designer must have installed sufficient protective equipotential bonding such that under earth fault conditions, all exposed conductive paths and extraneous conductive paths rise to the same potential. Okay? Again, meaning that all exposed paths should be at 0, or if a fault occurs, that any voltage exceeding 0 volts can be taken away from the point to minimize damage to the system. Now you see here it says conductor to remain unbroken, but normally it is unbroken, and it will just be picked up to here, then you just loop it into here and carry on. Okay, let's just make sure we got everything in view. We'll come back a little bit. Okay, thank you. Okay. Okay. See myself, I'm good. Now earthing. Earthing again. Under earth fault conditions, the current that flows will depend on a number of factors. These include the supply voltage, the value of earth fault loop impedance, any additional parallel paths. So here you can see that we have live neutral. Okay, we suddenly have a fault occurring on here, and suddenly it goes down to earth. That's all load. Okay. Now, if a fault occurs between here, that protective device should operate. Okay, main protective bonding conductors, etc. Earthing terminal in consumer unit. Okay. Same principle would be applied here. You'll need to make sure that everything is bonded down the ground and that your protective device will operate. Okay. Okay, let me go back a little bit, make sure we get everything in. Okay, I have everything in. Okay, thank you. Now, a circuit having a fault to earth, okay? And here you have your earth loop impedance. Your earth fault loop circuit, sorry. Earth fault loop circuit, my apologies. Okay, now I'm not going to go for this too much, but a fault occurs, and you can see that the path that it takes, okay? So a circuit having a fault to earth. Here a circuit is supplied from a PME supply giving us a TNCS system, okay? The TNCS system has a combined neutral and earth CNE prior to the intake position, after which the neutral and earth separates, okay? Under earth fault conditions, an unintended connection occurs between the line, conductor and earth. This is considered to be the start of the earth fault loop. Yeah. Just we have everything in play, okay? The fault. Think I have, okay, thank you, good. And here we have earth fault loop, okay? Just make sure we got that down. Okay. Earth fault loop, okay? And make sure you button that down so there's no missing out. Okay. Let's go in a little bit. The earth fault loop therefore consists of the connection between the line and earth at the origin of the fault loop, the circuit protective conductor CPC, the connection at the main earthing terminal. This usually exists within the consumer unit and is sometimes called the earth bar. The earthing conductor in a TNCS system to the combined neutral earth conductor, usually the arm ring of the supply cable. In a TNS system to the separate earth provided by the distributor, usually the arm ring of the cable, although can also be a split concentric cable. In a TT system to the general mass of earth via an earth electrode. And again, use your on-site guide. For a loop, the start point of the distributor's transformer, the phase winding of the distributor's transformer, the line conductor of the supply, the cutout at the intake position, the meter, the main switch usually in the consumer unit, the protective device for the circuit having a fault, the line conductor of the circuit having the fault, the connection between line and earth at the origin of the fault loop. Now, designing a circuit. What the designer has to do is to design circuit in such a way that the circuit protective conductor is large enough to carry the fault current that will flow on the fault conditions without breaking, large enough to ensure that the overall earth loop impedance is low enough to generate sufficient current to cause the protective device to operate within a set time. In later sessions, this will be dealt with in a more detailed, okay? And that will come in due course. but look back at some of the videos I've already done. Okay, and we're going to look at the multi-charge question. Now please do these questions. Okay. I'll come back a bit so we can make sure we can get them all in. Okay. I want you to be able to read these questions and do them, okay? Because it helps you with your own memory. And just pan back a bit so we can make sure we get it all in, okay? Okay, that'll be it. Okay, fine, thank you. I hope you found this useful. Okay, and I look forward to continuing with your sessions in regards to the NVQ. Okay, thank you. Bye for now.